Hi everyone, today we're covering topic 5.10, multi-step reaction energy profiles. So we saw this briefly before, but if we have a reaction profile with multiple steps, in other words, we have an intermediate somewhere in the reaction, we end up having two different transition states and this well directly in the middle of the reaction. Of course, we have our reactants on the left and our products on the right. Our first step will be this first bump that we see, and we have our first transition state and we have the first activation energy. And so we sometimes call this EA1. That's the energy needed to clear that first hump. It'll go to an intermediate. The second hump is our second step. We have a new transition state, an activation energy we call EA2 because that's our second one. And then it will go on to products. And so now you can see here that we end up having a method to also look at the overall exo or endo or overall enthalpy of the reaction. If we take the overall products that you end up at the end and the reactants, if I have delta H of this and delta H of that, I can subtract the products by the reactants and find the delta H of the whole reaction. We can also, just like we saw before, find the delta H of, for example, this first step, which would be the energy of these intermediates versus where you start. And then we can find the delta H of the second step, which I'll label in blue, which again is the energy of the intermediates and the difference from the products. And that is basically just Hess's law. And so this is a picture format of how you can calculate delta H using Hess's law and also think about multiple steps in a reaction. Generally, the number of humps that we see is the number of steps in the mechanism, and the largest one is the slow step. So in this case, step 1 equals the slow step, because that is the highest amount of energy required to actually start the reaction, whereas step 2 is the fast step, and we can actually see this visually. We need a lot of energy to get to the intermediate, but as soon as you get there, you basically don't need anything to get all the way to your products. So let's look at this practice problem right here. We have a reaction, 2NO2 plus F2 makes NO2F, and we have the delta H of the entire reaction, which is negative. And so what we know here is that products are going to be less than reactants. We'll call the products right there. Overall, this is an exothermic reaction. We're also told that we have two steps. Step 1 is NO2 plus F2 makes NO2F plus F, and that's slow. Second step is NO2 plus F makes NO2F, and that's fast. And so what we know here is that hump 1 is going to be higher than hump 2. And so now we can just draw out that energy profile. We'll have the energy go up, it'll go down, we'll have some sort of an intermediate. This is our F. And then again, we'll have some more energy, but it won't be as tall as the first one, and then it will go all the way down to our products. This is NO2F. And so this would be like one part of an FRQ question where you're just asked to sketch out what the energy diagram of this particular reaction would look like. That's all for today. Thanks, guys.